We'll keep on discussing the same as I was telling you that what the meaning of a square pyramidal is. See, this is a square and this is pyramidal. So one eye is here and remaining four eyes are here, and one more, sorry, I was saying that I, no, not I, it is F. So four F's are there on these four corners, and one will be there, one F will be there perpendicular to the plane of that. So on plane, these four, now 1 2 3 4, these four are there on the same plane, and one F will be perpendicular to that plane, and that will be towards the observer, and one can be not here exactly, it is not there, but one can be away from the observer, but it is not in this case. So I F5, or you can say BR F5. See, these four angles will be 90 degree, and this will also be 90 degree. So bond angle will be 90 degree. Bond angle will be 90 degree, and exactly it is not 90 degree. It is 84.8 degree, little less than, because of the presence of one lone pair. Why exactly it is not 90 degree? Why it is 84.8 degree? Because of the presence of one lone pair of electron. See, and see the angle, this angle will be 180 degree, this will be 180 degree, this will also be 180 degree. So because 290 degree, that is 180 degree, and the shape will be square planar, or you can say octahedral. One lone pair is also there, na? That lone pair will be like this. So if it is like that,
Yes,
then octahedral. So so square pyramidal, square pyramidal. So that is a square pyramidal. That's all over. It is this one. Now we'll take this example 4 plus 2. Now I'll take this example 4 plus 2. 4 bond pairs and 2 lone pairs. So that also means sp3d2, or you can say d2 sp3. That means sp3 d2, and shape will be square planar. So shape will be square planar. That is HEF4. HEF4. This example I gave you, na? And one lone pair here and another lone pair here. So two lone pairs. That is octahedral. Square planar or octahedral. This will be 90 degree. These four angles will also be 90 degree. And if you see the angle, these two angles between these two lone pairs or these two F atoms, it will be 180 degree. So I have taken just only XCF4, but you can take ICL4 minus also, and shape will be two lone pairs at its HCl, so less repulsion and more stable. Fine. So this is what the meaning of 4 plus 2 is. Now what I'll do, I'll explain you. This 4 plus 2 can be D2 sp3 also. This is sp3 d2, but it can be d2 sp3 also. In that case also, these two d will be dz square and dx square y square, and shape will be octahedral. CONH3 whole 6 3 plus CONH3 and 6 NH3 is 6 now, so 2 more NH3, and the charge on this will be 3 plus, because CO is 3 plus. In this, cobalt is showing D2 sp3 hybridization. So like this we will be doing this all. This is what I told you. 4 plus 2 till 4 plus 2 it is possible. It was there in our previous slide now. So now it is the new session, so that's why that is not visible here. So in this way we will be doing this all. Now what we will do, we'll do it from the beginning. What's the meaning of now? I think you can understand, you all can understand this all very easily. total pairs, bond pairs, lone pairs, steric number. Steric number means this number, total number of pair of electrons, this number, total number of electron pairs, that is a steric number, that is electron domains. And what will be the shape of that molecule, and what will be the bond angles, what will be the bond angle, and what examples can show this sp or sp2 or sp3d, like this all hybridization. And I'll explain you this NMR and electron diffraction method also. I'll explain you this too, electron diffraction, that is electron geometry, and this is molecular geometry. Here you will be considering only bond pairs, and here bond pair as well as lone pairs both. Now I'll tell you this also. See, if you will be taking NH3, I'll take NH3 as an example, NH3. Now see, in this NH3, first thing, how many lone pairs plus bond pairs are there? This is one technique. And in second case, how many bond pairs are there? Bond pairs are 3 H na, so 3 bond pairs, and 3H and 1 lone pair, that is 4. So lone pair plus bond pair, that is 4, and bond pairs are 3. This is NMR technique. This is NMR technique, that is nuclear magnetic resonance. What this technique is? Nuclear magnetic resonance. Nuclear magnetic resonance, that is classical concept. That is classical concept, old method. And this will be giving you average structure of molecule. And this is electron, this will give you molecular geometry only. What about this one? This is electron diffraction method. That is modern technique. This is modern technique. Fine, electron diffraction method, this is classical, this one is modern technique. This will give exact structure. This will give exact structure of molecule. That is electron geometry. That's electron geometry. It was molecular geometry, and here it is electron geometry. Now see, is this okay? What I'll do now, see, total is 4 na, so hybridization will be sp3. Total is 4 na, so hybridization will be sp3. And here it is 3 na, so hybridization will be sp2. This is what the difference is between these two methods, electron diffraction method and NMR technique. Is this okay?
Yes, sir.
Mesha, is it okay? These two are very means now I am trying to study this all once again, but even in net also it is very difficult to get. I tried a lot, but even Google also I was unable to get it. I was not able to found this all. So even forget about books, even in books too, this but I studied obviously somewhere, I don't remember exactly where I studied this all. So these are two different techniques, these are two different methods. That is what I am trying to tell you there in the next slide. Now we'll go back to the our previous screen. There we are talking about this all. What I'll do, I'll stop this and will now this is what now what we will do, we'll continue the same what we were doing. We'll continue the same. That is what I was trying to tell you. See, what's the meaning of 2? This is what I was talking about now, NMR technique and electron diffraction method. In electron diffraction method, you will be showing electron pairs, non-bonding pairs, and in NMR, you will only be considering bond pairs only. So only bond pairs you have taken. Lone pairs are shown here only in case of electron diffraction method. So like that in case of 3, that is sp2 hybridization, 3 means 3 plus 0, it means 2 plus 1 also. 3 plus 0 means lone pair 0, bond pairs 3. So domains, electron domains or steric number will also be 3. Shape will be trigonal planar. This is trigonal planar. 1 boron here and 3 F are here. This is what the meaning of BF3 is. Here no lone pairs, here lone pairs are also shown, but boron is not having any lone pair, beryllium is not having any lone pair. That's why we have not written it here. That's why we have not written it here. But when bond pairs are 2 and lone pair is 1, that is bent or V-shaped. That is bent or V-shaped. The bond angle will be 120 degree. Example O3 and SO2. O3 and SO2. So see, O3 is like this only. One lone pair and two bond pairs. One lone pair and two bond pairs. One lone pair and two bond pairs. So this oxygen in ozone will be having sp2 hybridization. This oxygen in ozone will be having sp2 hybridization. Two bond pairs and one lone pair. Now see, we will go to the next. Now we will go to the next. 3 is over. Now 4. Now we will talk here about 4. 4 means sp3. It can be 4 plus 0, 3 plus 1, 2 plus 2. Fine. Or it can be 1 plus 3 also. So how it is? 4 plus 0 means all 4 are bonding. Example is CH4. Then SO4 2 minus can also be there. Shape will be tetrahedral. Bond angle will be 109.5 degree. It will be like this only, CH4. SO4 we also know about SO4. SO4 this is SO4 2 minus. This is SO4 2 minus. So now 3 plus 1. 3 plus 1 means 3 bond pairs and 1 lone pair. Total is 4. Shape will be trigonal pyramidal. Example is 107.5. Bond angle is 107.5 degree. Bond angle example will be PH3, NH3, etc. NCl3, H3O plus. C 1P and 1P or 1N, then lone pair and 3H. What this shape is? This shape is pyramidal. What this shape is? Trigonal bipyramidal. What this shape is? Trigonal bipyramidal, and bond angle will be 105 degree. Examples already I told you. Then 2 plus 2, 2 bond pairs and 2 lone pairs. That example is H2O, and shape will be like this. Shape will be like this. These two lone pairs. These two lone pairs, bent or V-shaped. Bent or V-shaped, and it is here. Fine. So now this will be 2 plus 2 is over. Now there is one more that will be showing this C, P2 1s and 1d, so it will also be 4 na, that is d sp2 hybridization. Which d subshell it is, orbital it is not dz square, it is dx square y square, and shape will be square planar, bond angle will be 90 degree. How it is square planar? See, square planar means ni cn4, cn4, this is a square planar. 2 minus, this is a square planar. So like this, CONH3 whole 4 also, PTCl4 also, so will remain B. And if it is 1 plus 3, that is 4, shape will be linear. Example, HF, OH minus, so shape will be like this. So this is all about the 4. Now see 5. Now see 5. 5 means 5 plus 0. Now what you should do, 5 is already discussed here. Examples are new only, rest everything is done. So 5 is done. Then 6 is also done. 6 is also done. 7 is also discussed. So what you should do, you should go through this all, and then in next class we will start from here. I'll try to explain it from here. Fine. So in next class we'll start from here. So till here this table is very important. If you'll understand it properly, then your hybridization will also get over. So you'll enjoy a lot there than there in chemistry. Fine. Thank you very much. That's all for today.
Thank you, sir.
Thank you all.
Thank you.